let's say I asked you to take a binomial like 2x plus 3y, and I asked you to square it. All right, so you'd write 2x plus 3y times 2x plus 3y, and you'd FOIL it out, and you would get 4x squared plus 12xy plus 9y squared. Check my work on that, make sure I did it correctly. Do you believe me? Good. What if I asked you to take 2x plus 3y and cube it? I would take that answer, because that's 2x plus 3y squared, so I would take 4x squared plus 12xy plus 9y squared, and I would multiply it by 2x plus 3y, and I would get an answer, correct? Hope so. Hopefully I'd get a correct answer. Oh, the heck with the fourth. What if I asked you to take 2x plus 3y to the 8th? You'd say no. Okay, why not? What do you mean it's a lot of math? And I'm guessing there's an easier way, and the easier way is called the binomial theorem. That's correct. You would not take 2x plus 3y and write it down 8 times and FOIL it all out. You'd be here for a long time, and you'd probably make at least one arithmetic mistake along the way, and you wouldn't worry. At least one, I said. You'd probably make at least one arithmetic mistake along the way. All right, so let's go back to some easier stuff. 1 plus 1. No. How about if I just gave you a generic binomial, a plus b, and I asked you to square it? What do you get for an answer? A squared. If you FOIL it out, you get a squared plus 2ab plus b squared. All right, there's also a formula that you should have seen back in Math 1411 for cubing. Does anybody happen to remember the formula for cubing? You're thinking of a cubed plus b cubed. You're thinking of that formula. All right. Anybody remember the formula for taking a plus b and cubing it? You happen to get a cubed, don't tell Jay you don't remember, plus 3a squared b plus 3ab squared plus b cubed. That's pretty. Oh, I'm glad you like that. And this one's a completely different formula. We don't need to worry about that one for that. All right, one you probably haven't seen. There happens to be a formula for a plus b to the 4th. And I'll tell you what it is. And then we'll see if we can find a pattern here. This is a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. All right, so tell me about some patterns that you see. See any patterns? Okay, so I started with a square. I had 3 terms. When I had a cube, I had 4 terms. When I had a 4th, I had 5 terms. That's a good pattern. Okay. What else do you notice? All right, so what you're saying is you're looking along here, you see a 2, a 3, and a 4. So the next one would be a 5. That's good. That's correct. It's a pyramid. Okay. What do you know? What do you see about this pyramid? 24, but you're close. Not 12 either. All right, so we're looking at the coefficients. I'm going to write just down the coefficients. 1, 2, 1. And the next one was 1, 3, 3, 1. And the next one was 1, 4, 6, 4, 1. It is Pascal's triangle. Yeah, these coefficients are Pascal's triangle. So how does Pascal's triangle work? The next one is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and then a 1 on the end. So the next row would be a plus b to the 5th is, it starts with a to the 5th, and then we haven't talked about this pattern yet. What happens with the exponents on the a's? The a's go down 1 each time, don't they? And the b's go up 1 each time. So this one's going to be 5 a to the 4th b. So the power on a went down, the power on b came up. The next one's going to be 10 a to the 3rd b squared. And then the next one would be 10 a squared b cubed. 5a b to the 4th. And then finally b to the 5th on the end. Go ahead. What's the relationship between the Pascal's triangle and the binomial theorem? The answer is the Pascal's triangle gives you the coefficients that tell you how to expand something. So, if I wanted to do 2x plus 3y cubed, instead of having to FOIL it all out, I could use Pascal's triangle. So I use this row. This is the row for cubes. Oh, it doesn't take forever at all. Watch this. Because it says you do the first thing, which is 2x, and you cube it. Plus, the coefficient is a 3, so you write a 3 down. 2x gets squared, and then you have a 3y to the power 1. Plus, what's the next one? The coefficient is 3. 2x gets raised to what power? The 1. And 3y gets raised to what power? 2. Plus, what's the last term? 3y not squared. Alright, so then all you got to do is do the simple arithmetic. 2 cubed is 8, so that's 8x cubed. Plus, alright, a little bit of work here. 2 squared is 4. 4 times 3 times 3. That's 4 times 9. 4 times 9 is 36. X squared y. Plus, let's see, 3 squared is 9. And then I have 3 times 2, that's 6. 9 times 6 is 54. Xy squared plus 27y cubed. I think you'd have to agree that that's easier than even taking the 4x squared plus 12xy plus 9y squared and multiplying it by 2x plus 3y and doing all the multiplications and then finding all your like terms and adding them all together. All right. 2x plus 3y to the 12th. So the problem with 2x plus 3y to the 12th is what? You really don't want to have to make the whole triangle, do you? Even for 2x plus 3y to the 8th, that's kind of a pain in the neck. So, well, I don't know about simpler, but a different way. So if I ask you to do 2x plus 3y to the 8th, you have two choices. You write out 8 rows of Pascal's triangle, or you do something else, and here's the something else. What's that symbol? That's an exclamation mark. And what does it mean when I put an exclamation mark after an 8? I mean, 8! Really excited me? Anybody know that symbol? It does something special, that's true. There's a button on your calculator. What's that? It's function number 9. Correct. This is called 8 factorial. This is read as 8 factorial. And what it means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Who came up with that? I don't know. Mr. Factorial. I have no idea who first developed that notation. What's that? I don't know. So what's 8 factorial? Anybody got an answer for me? $40,320. If you push 8 and then hit the math button here, math button, and you go over to probability, factorial is there. 8 factorial, 40,320. Okay. All right, then there's a symbol called C, N, comma, K, which is also sometimes written this way. This symbol, C of N, comma, K, also written that way, is defined as N factorial divided by K factorial times N minus K factorial. And by the way, 0 factorial, to make our life easy, is defined to be the number 1. It seems weird, but we'll see why we want that in a minute. Zero to the anything except 0 is 0, like 0 squared is 0. 0 times 0 is 0. If you put any number to the 0 except for 0, you get 1. That's correct. All right, well, we'll see why we want it to be 1 in a minute. So let's say I asked you to do C, stands for choose, by the way. That's why it's called choose. So C of 3 comma 0, which is also written as 3 0. According to this formula, that would be 3 factorial divided by 0 factorial times 3 minus 0, which would be 3 factorial. So here's why we want 0 factorial to be a number. I don't want to be dividing by 0 here. That would be bad. Dividing by 0. What happens when you divide by 0? Your paper bursts into flames. Yes, that. Yeah. We don't want it to be 0.
It can be a 1.
Well, it's defined that way to make these formulas work. So that happens to be the number 1, doesn't it? 3 factorial divided by 3 factorial, that's the number 1.
Why is 3 over 2?
This is not a fraction. This is a different notation for this C thing. C of 3 comma 0 is also written as 3, 0 with parentheses around them, but notice I did not draw a fraction bar. So it's not a fraction, it's just there's two different notations for the same symbol. Okay? So what's C of 3 choose 1? That's also read 3 choose 1 quite often. 3 choose 1 would be 3 factorial divided by 1 factorial times 2 factorial. What's 3 factorial divided by 1 factorial times 2 factorial? A lot of factorials. What's 1 factorial? 1. What's 2 factorial? 2. What's 3 factorial? So this is 6 divided by 2. That's a funny way of saying 3. All right. I'm going to keep going. What's C of 3 choose 2? Any guesses before we work it all out? 6? Too big. 5, still too big.
4.
Still too big.
2.
It's too small.
3.
3, right. I knew you guys would make that guess. All right, so it's 3 factorial.
Wait, is it always what n is?
No. Divided by k this time is 2, so it would be 2 factorial. And then n is 3, k is 2, so 3 minus 2 is 1 factorial. What's 3 factorial divided by 2 factorial times 1 factorial? Not 3 factorial. It's just 3. It's the same answer we got last time, isn't it? 1 factorial times 2 factorial is the same as 2 factorial times 1 factorial. That's 3. All right, last one. C of 3 comma 3 is, that's 3 choose 3. It's 1. Why 1? Because 3 divided by 3 is 1? Because it would be 3 factorial divided by 3 factorial times 0 factorial. And 0 factorial is 1. Anything divided by itself is 1. Or I was really hoping you would notice the numbers. What are the numbers that we got? 1, 3, 3, 1. Where else did you see 1, 3, 3, 1? 1, 3, 3, 1.
Wait, but so they're only for 3, only for 3.
Yes.
You only go to what number, the number.
Right, so whatever number you start with on top, that's the biggest number you can use on bottom. So, another way to write this, if I had a plus b to the 5th, I could write down Pascal's triangle, or these numbers happen, the coefficients happen to be choices. It's 5 choose 0, a to the 5th, and 5 choose 0 happens to be the number 1. Plus, the next one would be 5 choose 1, and then the power goes down, the power goes up. A to the 4th, b to the 1. So you can work them out and try it. 5 choose 0, if you were to work that out, you'd happen to get the number 1. 5 choose 1, work that out, you'd happen to get the number 5. Well, pretty exhausting, I agree. The next one's going to be 5 choose 2. Again, work it out. 5 choose 2 happens to be the number 10. And then what are my powers? A to the 3rd b squared. What's the next one? It's a to the 2nd b cubed. What about the number out front? It's 5 choose 3. And then I need 2 more. The next one would be 5 choose 4. A to the 1, b to the 4th. Plus, finally, 5 choose 5. A to the 0, which I'm not going to write. B to the 5th. All right, well, it depends on the question. All right, so if I gave you 2x plus 3y to the 12th, I probably wouldn't ask you to write out the whole thing because that would take a long time and it would be a big pain in the neck. What I might ask you is, write the first three terms. On like an exam. Yeah, that's what I might ask you. Write the first three terms. All right, so what would the first term be? $12, choose 0. And A is 2x, so it would be 2x to the 12th. Plus, what's the second term? 12, choose 1. 2x to the 11th. 3y to the 1. Plus, go ahead. If you accidentally write a fraction bar, just erase it. I do that quite often myself too. Because you're so often when you write stuff like that, you're so used to writing a fraction. I'm surprised I haven't done it yet, actually, because I usually do. Maybe it helps that I have lined paper, so it looks like there's already a fraction bar there for me. I don't know. The next one will be 12, choose 2. 2x to the 10, 3y squared. All right, and then what you might do is take your calculator and do a little simplifying for me. 12, choose 0. That's 1. The first one always starts with a 1, doesn't it? So then I take 2 to the 12th. That's 4,096 x to the 12th. Yeah, I agree. Plus, what's 12 choose 1? But look at the triangle. When I had power fifth, the first number was a 5 for the second term. So to the fourth power, the second number was a 4. Third power, second number was a 3. 12 choose 1 is 12. So that's 12 times 2 to the 11th times 3. I'll work that all out in a minute. X to the 11th y. Plus, yeah, it's a very large number. 12 choose 2. All right, so I'm going to use my calculator. I type in 12, and then I go into math, and I go over to probability, PRB, so that's the probability, and I go down to number 3. There's your choose thing. 12 choose 2, and that's how you type it into your calculator. Or you can go 12 factorial and then divide by 2 factorial times 10 factorial, if you want to type it in that way. 66. So that's 66 times 2 to the 10th times 9 times x to the 10th y squared. So my final answer would be 4,096 x to the 12 plus 12 times 2 to the 11 times 3. What's confusing you? Yeah, I'm going to just multiply them all. 66 times 2 to the 10th times 9. 608,256 x to the 10 y squared. I don't know what the sign will do. I don't know what it wants for an answer. Yeah, I think I'll look in a few minutes. Say that again. The P stands for permutation. So the difference is, if 5 choose 2 stands for, if I had 5 items and I wanted to pick 2 of them, how many different ways is there to do that? That's what this symbol really stands for. If you have the P in front of it, that stands for if I have 5 items and I choose 2, but the order matters, how many ways is there to do that? So if I have like 5 students and it makes a difference which order I choose them in, that's called the P. Without the P, it's just if there are 5 students, how many ways can I choose them? I don't care what order they come in. Particular increase. The other question I might ask you is, I'll give you 2x plus 3y to the 12th. And I might ask you, find the 7th term. How would I do that, or why would I do that? Oh, well, that's a
I mean, I can
common
find
question.
the number of
The first number would be 12 choose 7? Close. All right, so look what we did here. The first term
12 choose 7.
had 12 choose 0. The second term had 12 choose 1. The third term had 12 choose 2. So if I'm asking you for the 7th term, is 12 choose what? So the answer would be 12 choose 6, 2x to a power, and 3y to a power. Then we've got to figure out the powers. And the way I think of it is this. Notice when I had 12 choose 2, this one was squared. When I had 12 choose 1, this one was to the first power. So when I have 12 choose 6, 3y goes to what power? The 6. Which means 2x has to be to what power? Why 6? Because they have to add up to 12. The powers have to add up to 12. So if I asked you to find the 7th term, there's the answer. 12 choose 6. And then you work it all out. So I grab my calculator, and I do 12 choose 6. 924. I multiply that by 2 to the 6th, and then I multiply that by 3 to the 6th, and I get a nice big number, 43110144, x to the 6th, y to the 6th. That would be my final answer. Questions on that? All right, my last question. How would it change if I put a minus in the middle? What's just negative? The answer is just negative? We're going to find the 7th term still? All right, the answer would still be 12 choose 6. And then I'm going to have a 2x to a power. And then I'm going to have, the only change would be, I'm going to have a negative 3y to a power. So if I have a minus here, I get a minus there. That's the only change. But in this case, my exponents are still 6. And negative 3 raised to an even power gives me a positive number. So how does it change the answer? For this case, it doesn't at all. But if I asked you for a different one, it would possibly make it negative, correct? Doesn't change this one at all. 43110144, x to the 6, y to the 6. So, just for example, if I asked you to do 2x minus 3y to the 12th, and I said find the 6th term. For the 6th term, I would have 12 choose 5, 2x to a power, and negative 3y to a power. What's the power on the y? The power on the x is 7. The power on the y is 5. This number always matches that number. And then you just add what plus 5 will give you 12. All right, so anyway, 12, choose 5, 792 times 2 to the 7th times negative 3 to the 5th. I get negative 2, 4, 6, 3, 4, 3, 6, 8, x to the 7, y to the 5th. So that's the only difference. If you have a negative in the middle, you deal with a negative right there. Sometimes you get negative answers, sometimes you get positive answers. That's about as hard as it gets right there.